Hello everyone, today we're gonna work on a linked list question. This is an easy question, also part of line 75, a reversal linked list. If you look at the example, it has a single linked list, 1, 2, 3, 4, 5, and as long as it's returned the reverse way, then the answer is good. 5, 4, 3, 2, 1. I'm just draw an example so it's easier to check. So as you can see here, we do have 1 is a head and 4 is a known. So basically what if essentially that we want to do is, so I'm gonna just draw it backward. So this is our initial goal. How we possibly achieve that? So what we are actually having is we have the next, but we do it a reverse way. So this is essentially is what it is. 3, 2, 1. And then this become head. And this is no. So how we are able to achieve that is we gonna use two pointer. One is pre and we need to point this node backward. So let's say we have 2. So we need to point this backward, right? So this is curve dot next. We have to go back to the previous one. For example, this is the previous one. We have to point it back to previous one. So we do it gradually. Everything's gonna go back. And what is, because we traverses to the next pointer, so we're gonna move our pre to the next one. So if we say this is curve, we're gonna move our pre to the current one. So if you can check this pattern, initially we have a pre as just a none, just a random pointer, doesn't have any point, and then a current one gonna be initial head, and then we traverse it slowly. So if you see can hear pre moving 1 point, and the curves also moving 1 point as well. Pre to the next and the curve to the next. And essentially what we have is we have when the curve is known, and our pre will be the thing that we want to return the pre, because it is where we have the head. So that is how we're gonna return this. So let's check it in the code. If you look at the pictures that I have, so initially we want to do a current dot next, because the current dot next we want to point it backward, so we have a pre. Okay, and our pre will move to the next curve, and our current, because our currents also move to the next node as well, right? But we're gonna initialize our next node equal to current dot next. So at this point, our current just be a next node. And after this loop finish, we just return the pre. Okay, that essentially that. We're gonna move to the code page, just rewrite it. So what we're gonna do, we are initialize the pre is equal to none, and our current will be equal to a head where we just started. And this only happen if the current is still available. So why current is not known? What we're gonna do? our current dot next will be pointing back to prev, and our prev move to the next, meaning move to become a current, and then our current. Also have to initialize our next node because our current dot next. So our current now become next node. After we're pointing back everything in the reverse way, we just return pre. So what is the time and space complexity? As the time complexity would be O of n, and n is the number of nodes in the linked list. Because like if iteration, we actually just process as one, and there's a n node in totals. What is the space complexity here? Because we didn't use any extra space for this algorithm, doesn't matter what is the input sign, so that is why we only use space O of n. Okay, awesome. See you in the next class. Bye.